In the last lecture, we discussed what a charge and the current is. Now we'll discuss something which is very strongly linked to both of these, and that is the voltage. The voltage is nothing but the energy that each coulomb has, or energy per coulomb. Now, as I discussed in the last video, that the main purpose of a charge is to transfer energy around the circuit. So, for example, if there's a charge, this is 1 coulomb, and it has 2 joules of energy. Joules is the unit for energy. So I can just say that this is 2 voltage or 2 volts. Now that is what the voltage of this charge is. That what that means is that each charge going through that point, it would have 2 joules of energy. So that is the voltage. Now something which is very interesting is that in a circuit we are not really interested in the energy per coulomb usually. We are actually interested at the energy that is used by a component. For example, this could be anything. For example, if this is a lamp, for example, we want to know that how much energy did this lamp take from that coulomb. So another term comes in which is called the potential difference. Now to explain that, I'll just tell you something before, that voltage is also called the potential. So the potential difference, as the name suggests, it is the difference between the energy of a coulomb between 2 points. For example, if this is a point in the circuit and there are some coulombs going through it, and we can just say that the voltage here is 5 volts, which means each coulomb has 5 joules of energy, and then the coulombs come back here and now they have just 2 volts, which means 2 joules of energy per coulomb. How much energy did this lamp take? Clearly the potential difference is 5 minus 2 means 3 volts. This is basically the energy drop or the potential difference drop across this lamp. So this is what the potential difference is. Now another convention comes into play, because if for example we have a circuit or a wire and there are 2 points, this and this, and I can just say that this is 6 volts and this is 2 volts. How do you know from which to subtract, like potential difference across these 2 points? Is it 6 minus 2 or 2 minus 6? Well, it's simple. The convention is that whatever direction the current is entering through, like entering into the circuit, for example, if I just say that the current charges are coming this way and they're entering this way, this would always be the positive terminal, and from where the current comes here, the current goes here, and then current goes out from here. The point where the current leaves, that is the negative terminal. So you always subtract the negative terminal from the positive terminal. So here the positive terminal is 2 and the negative terminal is 6. So the potential difference is minus 4 volts. Do not get confused by this minus 4 volts, as this is just the energy being supplied. If the potential difference is negative, the energy is being supplied. So negative means supplied energy, and positive basically means consuming energy. So this is something you don't need to worry about right now, but this is what it means. So I can just show another example, that for example, if this is a wire and I just say that the current is entering through here and this point is 8 volts and this point is 6 volts, what is the potential difference? Well, I can say that because the current is entering from this side, this is the positive terminal, and the current is leaving from this side, so this is a negative terminal. So the potential difference of PD is 8 minus 6, that is 2 volts. So this is how potential difference works using the convention. Now another very important element in a circuit is called the resistor. So the resistor is something that follows a rule. Now this is a weird definition, but we'll get more clear in a while. Ohm's law. It follows this rule. Now what the thing about a resistor is that, for example, if a charge is going, it needs to, like, expend its energy or use its energy between some place. So anything that resists the movement of a charge, that is called the resistor. Now some scientists, they played around with the resistor and they made some graphs and everything, and they discovered something, that if they take a resistor, and this is the symbol for the resistor, and they take some current which is going through it, and because the current is entering from here, this is the positive terminal, and the current is leaving here, so this is the negative terminal, and this is the potential difference, or V. If they plot a graph, they start off with a 0 amps current and the voltage was 0. Then they went to 1 amps current and the voltage across it increased 2. Then they went to 2, it increased. They constantly increased the current, and they discovered that such a graph was made. It was a straight line going through the origin. And any of you who are familiar with mathematics, this is a graph that shows linear relationship or a proportional relationship you know. So this kind of graphs, if it shows that the voltage across a resistor is linked to the current in such a way. You just multiply whatever the value of the resistance is, or some quantity or some constant. So this is what Ohm's law says, and this is Ohm's law, and this would really come in handy when we use it to solve some examples in the next in the next slide. But the potential difference across the resistor, it is linked to its current in this way: V is equal to Ri. Because resistor or resistance, this is the resistance. Resistance is a mathematical quantity, so its mathematical unit is the ohm, or more commonly known as this symbol. Now let me show this using an example. Now, for example, I have this circuit and there's a 3 ohm resistor and there's a 2 amps current going through it. We need to find the potential difference. So the first thing that I can notice is that because the current is entering from this side, this is the positive terminal, and the current is leaving here, so this is the negative terminal. So according to Ohm's law, the voltage or the potential difference across the resistor is the current times the resistance. So that means 2 times 3, and that would mean 6 volts. So this is the potential difference or the voltage drop across that resistor, and this is how Ohm's law works. So one last very important terminology is the power. The power is just the energy being supplied or consumed per second. Just excuse my band handwriting here, but this is consumed. So this is what power is. Now the power has a simple formula, and I'll just show that. For example, if if there are 5 charges per second going through a point, and the voltage is, or the energy each charge has, is 3 joules or 3 volts. Now this is the current, and this is the energy each charge has. So if I want to know the energy, or basically the joules per second, I can clearly see that because there are 5 charges and each one has 3 joules of energy, this is what would give me the answer of the energy being consumed per second. So this is clearly a formula that says that power is equal to the current times the voltage, and this is how this formula comes in. This is pure common sense. So this is the formula that you need to remember, and you can manipulate this formula into other forms. Like, for example, we know that the voltage is IR, so we can just substitute it here, and I times IR, because I just substituted IR for voltage, is equal to I square R. So this formula would also work in the same way. You just take the square of the current and multiply it by the resistance. So this is what power is. So let me just show the calculation of power using an example. For example, we have this circuit and we know the potential difference between these 2 points, and that is 3 volts, and then there's a 2 amps current entering through. And one thing to remember is that whenever you are finding power, you will follow the same conventions. You will take the current that is entering the positive terminal, and then you will multiply it with the voltage. So here the current entering the positive terminal is 2 amps, which is the formula was IV. So I is 2 amps and the voltage is 3. So the power is 6 watts. This is the unit for power, 6 watts or joules per second. We just use watts usually. So 6 watts basically means that the energy being transferred between these 2 points is 6 joules in a second. So I'll just change this example a bit, and for example, let's assume that it's the same circuit exactly, and then there is a potential difference of 4 volts, but this time the current is entering through here, and that is a 3 amps current. Now we need the current that is entering through the positive side, but this is the current which is entering the negative side. So as you know, as I told in the last video too, that if you want to like reverse the direction of the current, you just add a negative sign. So there would be a minus 3 amps current entering this side. So I can just say minus 3 times the potential difference, which is 4. So minus 12 watts. Not get confused by this negative sign. This is just the same as in voltage. The negative sign means that there is power being supplied in this circuit. So this is how the signs work. So I hope you understand this. I hope you understand the sign conventions, and I hope you now know a bit about how to apply these formulas.